Hello everyone, welcome to Education Channel and this is Srinath. It's Diwali time, I am at my native place. You might hear some disturbing noises, so please ignore all of them. Don't mind. Okay, so today we are gonna start a higher level topic, that is atomic structure, or this is also known as spectrum, and this is an important topic in quantum mechanics. And quantum mechanics is a mechanics or a branch in physics or a type of physics. So this is gonna start with a very simple example. So I think we have uploaded this. So in our previous videos, one of our videos, I have explained about the wavelength and energy by drawing the waves, right? So how is this true? How can we prove it? So for this, we have many equations. So I'm going to start off with one. E is equal to hc by lambda. So where h is Planck's constant and c is speed of light. And we have divided by lambda, right? So that lambda is the wavelength. So I had drawn a wave, right? So the distance from this peak to this peak is the wavelength, or this trough to this trough is the wavelength. So the energy of the wave is inversely proportional to lambda or the wavelength, because h and c are constants, speed of light and Planck's constant. So whatever you do, you increase the energy or decrease the energy, the constants remain the same, right? So while deriving a variation, you need not to consider the constants. So the constants are not useful at all in case of variations, because they're constants. If you differentiate them or integrate them, you will get if you differentiate them for the variation, you will get 0. That is, there is no change. Okay, so hc by lambda, and it is, as it is in the denominator, you have the inverse variation. Energy increases, wavelength decreases. That is, it will have very small distance, like X-rays, alpha rays. Okay, and we have another equation. E is equal to h nu. H is Planck's constant everywhere. That is true. What is nu? Nu is the frequency of the wave. The frequency. So it is, we have also read that it is the number of oscillations per second. That is somewhat similar to the waves. The waves passing through a fixed line in 1 second. The number of troughs or crests. So this is frequency. And as E is equal to h nu, h is Planck's constant, ignore it. Then you have E is proportional or directly proportional to nu. So if it is proportional, as energy increases, frequency also increases. So the shorter the wavelength, higher the frequency, higher the energy. That is one variation. And E is equal to hc nu bar. So what is nu bar? Wait. E is equal to hc by lambda. E is equal to hc nu bar. So we can equate those equations. We have E is equal to hc by lambda and hc nu bar. Then you can cancel hc and hc on both sides of the equation. Then you will get lambda or 1 by lambda is equal to nu bar. That is, the reciprocal or the inverse or 1 divided by the lambda or the wavelength is your wave number. So that is the wave number, and you can also say that if energy increases, lambda decreases, frequency increases, wave number increases. These are the variations, these are the basics for atomic structure, or this is also a very important topic in chemistry and a part in atomic physics and quantum physics. So this is all, and we have many equations apart from this. So we have also heard about the famous equation E is equal to mc square, right? Einstein's equation, energy and mass relation. So if we take that and equate it to E is equal to hc by lambda, what we get? Let's see. E is equal to mc square, E is equal to hc by lambda. So m into c, hc. Then this c gets cancelled and another c gets cancelled. Then mc is equal to h by lambda. So mc is equal to h by lambda. Then lambda is equal to h by mc. That is one step. Now you have the Heisenberg equation, the Heisenberg uncertainty principle equation. So you have lambda is equal to h by mc. Now wait, Heisenberg uncertainty principle says that a particle can be anything, not only a wavelength or a wave. See, a wave travels at the speed of light. But not all objects travel at the speed of light. So you cannot say that the speed here is constant. So the c can be removed because c is constant, and according to the principle, velocity is not constant. Then you can replace it with a v, just representing that velocity can be anything and it's not constant. So lambda is equal to h by mv. This is Heisenberg's uncertainty principle. And we have another topic about Schrodinger's equation. This is a very high level topic, but this starts off from a very simple example. So according to this principle, the quantum computers also work. What is this? So Schrodinger, he's a scientist, he's a German scientist. He tries to simulate something. He imagines that he puts his cat inside a box and he closes the box. After some time, he wants to open that box, and before opening it, he wants to predict that whether the cat is alive or dead. What would we do? Probability, it can be either alive or dead, 50-50. But he says that the cat is in superposition. What is superposition? So it is having two states at the same time. He says that there is not probability of 50-50. There is 100% probability of being alive or 100 of being dead. And that 100 and 100, they are not a part of 50-50. They are different. He says that the cat is half alive, half dead. So this is not possible, but according to the probabilities and the calculations he did, he was correct. So why are these used in quantum computers? Quantum computers we have heard that they can break any safe, any encryption codes, etc. And they can decrypt any computer. How is this possible? Because we have an encryption code, and that code has zeros and ones alternating between them. And not all computers are as fast as quantum computers and supercomputers, right? So as they have alternating numbers, we cannot break quantum computers also, because they are in a superposition, either 1 or 0. So when you try to flip a switch or a transistor switch, the qubit is either in the 0 or the 1 state. So if you try to think of 1 and flip it, it will be 0. And if you try to think of 0 and flip it, it will be 1. So you can never predict a quantum computer. That's why they are used in military purposes in many militaries and many countries like Russia. So that's all. Started from a small cat and it went to a quantum computer. Okay, thank you. Make sure you like and subscribe.